Yeah, that happened to my computer once, where I got the Windows 10 update, but it updated everything except my network drives, so I could no longer connect to the internet
Fun.
on my computer. So I literally had to buy a $100 key to update my
The
computer,
whole thing.
even though I should have gotten the free update.
Yeah,
I was.
I bet. All that just became part of the notes. Should I repeat the video? Or should we let Marina listen to all your
She's fine. She listens to this stuff.
Okay, exam 3 review. We have different approaches. You do need your little cheat sheet, and it's been updated with all the formulas there. I tried to get rid of some stuff, made some other stuff small. It just depends. Now, for the first two problems, we are going to solve each equation, each on the interval of 0 to 2 pi, sorry. Now, these problems are not that bad. If I have 1 minus sine equals 1/2, and you're trying to solve for sine first. So what's the first thing I have to do here in order to solve for sine? Subtract 1. So I get negative sine equals a negative 1/2. And then?
Would multiply both by -1.
Multiply or divide everything by a -1, so we could make both sides positive, and then we have a positive 1. So where is sine a 1/2? And remember, sine is your y. So when is your y a 1/2? At pi over 6 and?
No, 5 pi over 6.
And 5 pi over 6, which is right there. So at those two. So my answer for this problem is pi over 6 and 5 pi over 6. Questions? So once again, we're solving for whatever cosine, sine, or tangent that they give you. We're trying to see what answer, because sine is the y. You're trying to go around your unit circle and see when is y 1/2, and it's at both of these places. Now for problem number 2, you got tangent squared equals to 3. What do I do to find the solve for tangent? We take the square root, so I get the tangent is both positive and negative square root of 3. So I am looking to see when do I get a positive negative square root of 3. Now, your tangent comes from doing y over x. So the only possibilities that I have here, and this is where you need to kind of analyze this. If I have the square root of 2, square root of 2, that's not going to give me no square root of 3. This guy, if I have 1/2 on top over the square root of 3, that's not going to work. How about when I have the square root of 3 over 2 divided by a 1/2?
Yeah.
Yes, and in case you need to see the work to that, because sometimes I still need to see some work, this is y over x, but remember this becomes a square root of 3 over 2 times the reciprocal of this, which becomes 2 over 1. That cancels, this is just the square root of 3. So as long as you have this point, whether it's positive or negative, 1/2 and the square root of 3 over 2, which also happens here, negative 1/2 square root of 3 over 2. This is a negative negative, which becomes positive. This is a positive negative, which becomes negative. So I should have those 4 answers, which is pi over 3, and then 2 pi over 3, and then 4 pi over 3, and 5 pi over 3. So these are my 4 places where tangent is going to be plus or negative square root of 3. Are we okay there? Yes? All right. So please understand your answer should look like this. There's no reason why I should get decimal places, decimal numbers, and any of this. For number 3, so that's it for 1 and 2 under those instructions. For 3, I have solve each trig equation in the quadratic form. So let's say you have a problem that looks like cosine squared plus 2 cosine plus 1. Now, I don't know if you recall that when we were doing this lesson, I would change your numbers to x's, and so you could see it a little bit better. So it's like having x squared plus 2x plus 1. How do you factor something that looks like x squared plus 2x plus 1?
You do the A times C and the B chart and figure out which one is multiplied.
Okay, so what two numbers multiply to 1 and add up to 2?
1.
1 and 1. So this would be x plus 1 and an x plus 1. But when we're talking about the trig functions, it's going to cosine plus 1 and cosine plus 1. Now, what did we have to do after that to actually find the answer? Set them equal to what? To 0. So cosine plus 1 is equal to 0. Cosine plus 1 is equal to 0. And of course, I'm going to get the same answer, right? Cosine is a negative 1. Cosine is a negative 1. So when is cosine? In cosine, we're talking about x. When is x a negative 1? Only at pi. And that is my only answer. That's it. So you're going to get something that looks like you could factor out. So if it says quadratic form, you need to think, I need to factor, I need to reduce something here. You're not trying to make something another equation or anything like that. Number 4, 2 sine squared minus sine equals to 0. It's like having 2x squared minus x. What do they have in common? An x or a sine, right? So if I factor out a sine from both of these, I get sine equals, what's left over if I factor out one sine? 2 sine minus 1 equals to 0. How many things do I have here? 2. So I have to do sine equals to 0 and 2 sine minus 1 is equal to 0. Now this one's already solved. So when is y a 0? At 0 and?
360.
And pi? Pi. Don't forget 0 and pi. So both 0 there, 0 there. Now this one becomes 2 sine of a positive 1, then sine becomes a 1/2. So when is y a 1/2? And we already did that one here. So it's a pi over 6 and 5 pi over 6. Pi over 6 and 5 pi over 6. We're done with that section. This right here, it's 7.3, just in case you need to go back and see more stuff. That is 7.3 because your test starts 7.3 to 8.3. Questions on 7.3? Are we okay? Yes? Most we could be. Now for 7.4, we have to simplify in this section. So let's say you got 1 plus cotangent, 1 minus cotangent, and minus secant squared cosecant. I said secant squared. So the question here is, I need to simplify, so I need to see if this could just become one thing. So I'm going to look at secant cosecant squared, and the only place I see a cosecant squared is right there. Now, cosecant squared is 1 plus cosine. Alrighty. 1 times cotangent. Sorry. Now, my question here is, can you do something here? We could FOIL. So if we FOIL, this becomes 1. 1 times a negative cotangent is a negative cotangent. Cotangent times 1 is a positive cotangent. And a cotangent times a negative cotangent becomes a negative cotangent squared minus, I'm going to keep this as this right now. Now, what happens with these two little guys?
Cancel out.
They cancel. I have 1 minus cotangent squared. But this could be exchanged into what? 1 plus cotangent squared. But this negative affects both of those. So this becomes negative 1 minus cotangent squared. What happens to this 1 and this negative?
Cancel out.
They cancel. And I just have a negative cotangent minus a cotangent, which gives me a negative 2 cotangent squared. And this is you simplifying.
You weren't supposed to take the 1 minus cotangent squared and put that in the cosecant squared?
This one,
Yeah.
you couldn't because your cotangent is positive. I know. When I was trying to work it out, that was the first thing I tried to do. So if you can't change that to that, then change this to that. You're only going to get one problem, or you're going to have to kind of do something like this. Cosine 1 plus sine plus tangent. So let's look at this one. So since this is in cosine and sine, and this is in tangent, could tangent be changed to something like this? What is tangent? Sine over cosine. So I'm going to rewrite this plus sine over cosine. Now, would I be able to add those two? No, unless they have the same what? Denominator. So in order to have the same denominator, I have to multiply this side, both top and bottom, by cosine. And this side, both top and bottom, by 1 plus sine. 1 plus sine. Now, what does cosine times cosine become?
Cosine squared.
Cosine squared. Do we distribute in the bottom, or do we keep it like that? It's up to you. You could try one way, or keep it, or put it together, and then figure out if we're right or wrong, because that's the way it's going to be on the test. You're going to have to play around with it.
I would just keep it in parentheses.
So you would keep it for now? Okay, that's fine. Now, on this side, do you want to keep it or multiply?
Multiply it out.
Multiply that one, so we get sine plus
Yes.
sine squared over cosine, 1 plus sine. Now I'm going to rewrite this as 1, putting stuff in order. So I have cosine squared plus sine squared plus sine over cosine plus 1 plus sine. Now, every time that you see this together, you need to think of something. What does that become?
1.
A 1. So according to this, sine squared plus cosine squared is always going to be 1. So this here becomes 1 plus sine over cosine, 1 plus sine.
Can you cancel those two out?
Oh, what can we cancel?
The 1 plus sine.
These cancel. Okay, so I have a 1 over cosine,
Which can be a.
which could be a secant. So that should be as far as you can take that. If you would have left it like that, I wouldn't have taken off too many points or any at all. But if you could do this, please go ahead and continue. Questions? Establish the identity. Number 7, tangent times cosecant. You want for it to equal secant. So in this one, they actually give you this has to equal to this. So you have to manipulate these two so it equals to secant. And that's what you do when it says establish the identity. Make sure the front equals to the back. Now, secant, and just so we could get an idea, secant is 1 over cosine. Can I change this to something that has a cosine?
Sine over cosine.
So this becomes sine over cosine. Can I change cosecant to something?
1 over sine.
1 over sine. And then when you look at that, guess what you can cross out? Your sines, and I get 1 over cosine. And what is 1 over cosine?
Secant.
Secant. So there. I did all the work to make sure that it's equal to that.
And we're not going to have to do that with a half angle identity, right? Okay.
I'm going to look into it. Just so you know.
It's so annoying. It takes forever.
So this is it for 7.4. Just the key parts, how to simplify, how to establish. Are we okay with that? Yes? All right, so 7.3, 7.4, we're done. 7.5. Find the exact value. Now, please understand, every time it says that, find exact value, it doesn't mean plug it into your calculator. I need to see some work. It means you use your unit circle. You need to somehow show me you're using your unit circle. Now, if I give you problem cosine 5 pi over 12. When we were doing the notes for this one, we agreed that it was easier to change this into degrees, right? So in order to change this into degrees, I have 5 pi over 12 times 180 over pi. And can somebody tell me how many degrees we're talking about?
1,008.
You're cray-cray. It is 75 degrees.
Oh, I thought you meant just 5 times.
75 degrees. So it's 12 times 180 divided by 12. So this is really finding cosine of 75 degrees. Because I have to use the unit circle, this is going to be a sum and difference. This section, this is when we do the sum and difference. What two numbers add up to 75?
45 and 30.
45 and 30. So this becomes cosine of, I'm going to put 30 plus 45, smallest degree first. It should give you the same answer either way. It does. So cosine, and this is a sum and difference. So we're going to do cosine of an addition, of a sum. This is the formula you would have to use. So this is cosine of 30, cosine of 45, minus sine of 30, sine of 45, using your sum and difference identities. So cosine of 30, we're talking about the x of 30, and my answer is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. So square root of 3 over 2 times the square root of 2 over 2. Sine of 30, the y value is 1/2. Sine of 45 is the square root of 2 over 2. And this here becomes square root of 6 over 4 minus the square root of 2 over 4. You can keep it like that, or square root of 6 minus square root of 2 over 4. Write it down as 1. How bad is that? It's not bad, Miss Peña. It's the easiest thing I've ever seen. Tangent of 13 pi over 12. What is 13 pi over 12? Times 180 over pi. How many degrees is that? $195. So I have tangent of 195 degrees. So tangent of 195 degrees can be broken down into
60 and 135.
Okay, well, I did 150 and 45, but I guess you guys will make me use my heads. What do y'all want to use?
15, 135.
50, is there 145 on there? You can't use 145. Because remember, you have to use numbers
What
from
did you do?
your unit. I did 150
45.
and 45. What did you say?
60 and 135.
Okay. Sorry. Either one is good. But yes, you could use those. My bad. I didn't. Alrighty. So tangent is different. Tangent of 150 plus tangent of 45 over 1 minus tangent of 150 times tangent of 45. When you use tangent, you're probably going to end up with fractions because you're using two values, y over x. So I'm going to go here on the side and first figure out what each of these is. For tangent of 150, and remember it's y over x. So for 150, my y is what? 1/2 over my x, which is the negative square root of 3 over 2. So this becomes 1/2 times the reciprocal of this one, negative 2 over the square root of 3, which gives me negative 1 over the square root of 3. And then what do you have to do with that?
Multiply both sides by square root of 3 or multiply by square root of 3 over square root of 3.
Multiply by square root of 3, square root of 3. So this becomes negative square root of 3 over 3. This is for the 150. Are we okay with that? Now, the tangent of 45 is the square root of 2 over 2, and the square root of 2 over 2, which just gives me what? 1. So we already have both of the things we need. Now we can come back and plug in. So that way we don't have all these crazy fractions in there, like of us trying to do all that. So tangent of 150 is the negative square root of 3 over 3 plus 1 over 1 minus square root of 3 over 3 times 1. What do I have to do with this 3? What do I have to do with this 1? 3 over 3. Why am I putting 3 over 3? So I can have the same denominator. So this is going to become negative square root of 3 plus 3 over 3 over, what happens with this negative and negative? It becomes a positive. And what do I have to do with this 1 also?
Make it a 3 over 3.
Make it a 3 over 3. So this here becomes 3 plus square root of 3 over 3. Any questions there? So negative square root of 3 plus 3 over 3 times the reciprocal of your denominator, 3 over 3 plus square root of 3. What happens to your 3's? They cancel. So I'm going to rewrite this like this so they could look almost the same. So I just reordered the top, switched them, and the bottom stays like that. But who is wrong? Your what? Denominator, because you cannot have a square root whatsoever in your denominator. So I have to rationalize by multiplying 3 minus square root of 3 and 3 minus square root of 3. So top and bottom, you have to multiply by the conjugate of your bottom. So if this is a plus, this is a negative. If this is a negative, then you do a plus both on top and bottom. You do FOIL on top, FOIL on the bottom. Or distributive property, whatever you want to call it. So 3 times 3 is 9. 3 times the negative square root of 3. Negative 3 square root of 3. Negative square root of 3 times the positive 3. Negative 3 square root of 3. Plus the square root of 9. Over 9 minus 3 square root of 3 plus 3 square root of 3 minus the square root of 9. Now what happens to your middle terms on top? They become what? Do they cancel? No. A negative 3 and negative 3 becomes a what? Negative 6 square root of 3 plus, what's the square root of 9? 3. All this over 9, what happens to the ones in the middle and the bottom? Those do cancel. And what is the square root of 9? 3. So this becomes 12 minus 6 square root of 3 over 9 minus 3 is 6. And this reduces to 2 minus the square root of 3. Whew. Fun? Now, I need for you to understand this here is not wrong. It's just it's not correct mathematically. So just in case, some of you believe you're going to get lost from here to here, and just so you could check your work, we're going to put you right there. If you want to check your work, this is 3 minus the square root of 3 divided by 3 plus the square root of 3. So that's what I get. So if I enter my final answer, which is 2 minus the square root of 3, is it the same thing? Yes. So you could kind of check to see if your final answer looks like this before you rationalize, just so you could have that peace of mind. I did all that work right. Or it's like, oh crap, it's not the same. I must have done something wrong. So you could do that so you could kind of check what you're doing. Are we okay? All right. Number 10. Sine of 245 cosine of 5 minus cosine of 245 sine of 5. So in this one, they are already using the difference or the sum, but you're trying to figure out which one is it. So it's sine cosine minus. Sine cosine with a minus, so it is this one, right? So it is the sum of the sine, because it's sine cosine, cosine sine. This becomes sine of 245 plus 5, which becomes the sine of, I'm sorry, it is the subtraction one, so it's the one with the minus, of course. I don't know where I left it. This is the minus, so what is 245 minus 5?
240.
240. And because I'm just looking for sine of 240, I go here, sine of 240, there it is. I only care about my y, and my y is the negative square root of 3 over 2. And there's your answer. So you're going to have both types. The one where you have to go and figure out which two numbers, and then the one where you have to figure out the other parts. Questions right now? No? Oh, sorry. Sorry. I don't know where I left my whiteout. There's everything. Okie dokes. Now, the next one, number 11, 1 minus tangent of 80, tangent of 70, over tangent of 80 plus tangent of 70. Now this one's a little bit different, but you should still be able to do it. But obviously we're using the tangent one. It's the sum or the subtraction. It's a subtraction. It's a sum, right? Now, the only thing with this one is your sum is which way? Isn't it backwards?
Mm-hmm.
So I am really doing, this is 1 over tangent. This is not tangent, but it's 1 over tangent. But which are the two angles that we're using? And what am I doing with them? Adding them. So this becomes 1 over tangent of 150. So this becomes 1 over, tangent is y over x of 150. What is my y in the 150? 1/2 over the negative square root of 3 over 2. So this is 1 over 1/2 times the reciprocal of that. 2 over the negative square root of 3. Those cancel. 1 over 1 negative square root of 3. So it's a lot of math and rationalizing and fractions and multiplying times the reciprocals. It's a lot of that. So this is 1 times negative square root of the reciprocal of that, which is just the negative square root of 3. Math. Remember, no member. Remember all that? Yes? Still have 1 hour to finish. Yay! All right. Next one. find the exact value. Under the given conditions. So for number 12, they give you sine of alpha is 3/5. And we are between pi over 2 and pi. And they also give you cosine. It's 24/25. And we're between 0 and pi over 2. And they want you to find, so we're still in the same section. We're still in 7.5. It says the difference of two angles, but they're giving you this information. And I think we're just going to get one problem from this section because it does take a lot of work. So just so you know. Now, first thing is we need to understand that sine is what over what? Y over R. I need to somewhat draw a little triangle. We are between pi over 2 and pi. We are between pi over 2 and pi. I am drawing my triangle here. I know that my y is 3, and I know that my radius is 5. But I'm still looking for my who? The x. So I use x squared plus 3 squared equals to 5 squared. So x squared is 25 minus 9. So x squared is 16. We take the square root, and we know it could be a plus or minus 4. But because of where it's located, the only one that we could use is which one? -4, right? Now, with this information, I should be able to tell you who is cosine of this angle. And the cosine is, -4/5. So I'm going to use this and this in a little bit. But now I have to work with my other angle. And then this one happens here because it's between 0 and pi over 2. They give you cosine. Cosine is x over r. So then this part is 25. This part is what? 24. So who are you looking for?
23.
It's not a 23. So I have 24 squared plus y squared equals to 25 squared. Y squared is 25 squared minus 24 squared. Y squared is 49. If you plug it in, and the square root of 49 is plus or minus 7. But because of where I'm at, is your y going to be positive or negative here? Positive. The only one you could use is the positive y. That's the positive 7. So my sine for this angle is my y, which is 7/25. So I'm going to use that one and that one in a little bit. Because they ask you to find this. Look at my notes. And there's a difference of A and B. So I need sine, cosine, minus cosine, sine. So change that to all that, and then we plug in the values. Who is sine of alpha? 305 times cosine of beta, 24/25, minus cosine, -4/5 times the sine, which is 7/25. So when I do that, 3 times 24 becomes 72/125. This becomes a plus. 4 times 7 is 28/125. That becomes 100/125, which reduces to 4/5. And that's your final answer. You will definitely have a problem like this, and it is definitely going to be worth a lot of points. Because there's so much work within it. So please make sure that you understand this. Okay. One last problem for 7.5, which is problem number 13. And this one's an easy one. Cosine of x plus pi over 2. And I need to make sure that this equals to sine of x. So I need to do something with the sum of the cosines, and somehow it has to equal to that, knowing that my two angles are x and pi over 2. So this addition becomes cosine of x, cosine of pi over 2, minus sine of x, sine of pi over 2. So I'm just substituting it into the two angles for the difference or the sum. Cosine of x is just cosine of x. But what is cosine of pi over 2? 0. Sine of x is just sine of x, but what is sine of pi over 2? 1. So this times 0 becomes what? 0. This times 1 is just sine of x. So isn't this a negative sine of x? Has this equal to that? So that is it for 7.5, 7.6. Find the exact value. So I have cosine equals 21/29. They tell us we are between these two things. And they want us to find the double angle of sine. So this one has to do with double angles. So just to know, double angle of sine is where now? Where did it go? Right there. So I need to know both sine and cosine. So I have to do some work here. Now I can tell you this much. I have a triangle. It goes like this. Oh, I even drew it in the wrong place, right? Aha. It's right here. This is 3 pi over 2, and this is a 2 pi. Now cosine is y over x. Do we agree? No, just kidding. The cosine is x over r. I don't know why I'm thinking tangent. X over r. So sorry. So my x is 21. My radius is 29. I have to figure out who my y is going to be. So I have 21 squared plus y squared equals to 29 squared. Y squared equals 29 squared minus 21 squared. Y squared is 400. We take the square root of this, and I get that y could either be a positive or negative 20. But because of where I'm at, your y's are what here? Negative. So the only one I could use is the negative 20. It has to be a negative 20. So I need to find out who is my sine of the angle, which is the negative 20 over 29. because it's y over r. And then for a double angle, if you look at the formula that you're following right there, we said that sine of the double angle is 2 sine cosine, which means 2 times sine, and sine is negative 20 over 29 times your cosine, which is 21 over 29. So we're just using these numbers and plugging them into the formula. So 2 times 20 times 21 is 840, and 29 times 29 is 841. And that's your answer. You can't do more than that. So this was for the double angle. Now we're going to do one with a half angle. So for this one, they tell us, hey, sine is 1/4, and sine is y over r. And I am graphing this. You know how here they give you between here and here? On this one, this is all they say. Tangent is greater than 0. So my question to you, when is tangent positive? So this is where you need to use this one. And tangent is positive both at quadrant 1 and quadrant 3. So for this one, I have to draw a triangle here, but also a triangle there. But we need to use the information and figure out if this is possible or not. Now, my y is 1. My radius is 4. Can my y be a negative 1? And this still be true? So this one's not going to work. This is going to be a no. This is the only one you're going to be working with. Now, if it could have been, then you would have to do it twice, but that's not the case. X squared plus 1 squared equals to 4 squared. X squared equals to 4 squared minus 1 squared. So x squared equals to 15. I get the square root. And it's a positive negative square root of 15, but your x is going to be what here? Only positive, right? So this is the one I have to use. So, oh, and I didn't tell you what you're supposed to find, sorry. You have to find cosine of the half angle of cosine. Now the half angle of cosine, so I need to find cosine of this, and cosine of this angle is square root of 15 over 4. Now the cosine is the square root of 1 plus cosine over 2. Sorry. So 1 plus the square root of 15 over 4 over 2. That 1 needs to become what? 4 over 4. So this becomes the square root of 4 plus the square root of 15 over 4 over 2. And that becomes 4 plus square root of 15 over 4 times 1/2, the reciprocal of this one. And that right there becomes the square root of 4 plus square root of 15 over 8. You could just leave your answer like that. Or if you want to reduce, you could do 1/2 plus square root of 15 over 8. It's the same thing. That's what you would have.
So why would the 4 plus square root of 15 over 4 over 2 become that times 1/2? Would it become,
Because of this, because it's all
oh,
of
because that
that.
would be, oh.
Yeah. The last one from this section, from 7.6, is when they give you half angle like this. They give you cosine of 22.5. Now, if they tell you this is a half angle, how much is your entire angle? It is 45 degrees. Yes? Alrighty. So knowing that this is really cosine of 45 over 2, which means 1 plus cosine of the angle over 2. But what am I going to put in here? 45. So this becomes 1 plus cosine of 45 over 2. And what is your cosine of 42? I mean 45. I don't know why I'm saying 42, so sorry. Square root of 2 over 2. So that means this one has to become what? 2 over 2. So 2 over 2 plus the square root of 2 over 2 over 2. All these beautiful 2's. Oh, life without 2's would just be so sad. So square root 2 plus the square root of 2 over 2 times a 1/2. 2 plus square root of 2 over 4. You could reduce square root of 1/2 plus square root of 2 over 4. And I am okay with that. You can reduce many other ways. It just depends. Yes, ma'am. It's in 15. Yes.
What do you use the sign of the
When would you what?
The sign.
Uh-huh.
How do you use it?
The plus minus?
Mhm.
In case this worked, there was one problem where we did have to use the minus. And the assignment also? I can't remember right now. I would have to look at the notes to be honest. But I think when you would have to use it is when the angle itself is negative. I think that's when it was. Because you see, for the sign, when the angle is negative, you have to take out a negative. So it's like a negative within a negative, and then that's how it becomes a positive. We did one in the notes. I would have to look at it again, and we could look at the problem from your assignment. Okay, so this is it for 7.6. It's going to go faster after this. Sorry. Whoops, there it is.
So if we get 2 plus square root of 2 over 4, we can just leave it like that. No, we don't have to simplify it to 1/2 plus.
You don't have to. I'm okay with you not doing it. Okay? Alrighty. Okay. So, we only have 2 more pages and that's about it. So we're almost there. 7.7, it was, you're gonna have only 2 problems. We're gonna go products as sums, and then you're gonna have one where you have to go sums of products. So, what number are we on? 17, thank you. If I have that sine of 5 and sine of 2, So this is a multiplication of signs. And here's the multiplication of signs. And it has to become this part of the equation. So you would be using this one. So it becomes a 1/2 cosine of 5 theta minus 2 minus cosine 5 plus 2. So these are probably the easiest problems that you're going to have. As long as you have the formula, you should be okay, because all you do here is just combine. This becomes cosine of, what's 5 minus 2? 3. And this becomes minus cosine of 7. And that's it. That's all you do here. You're rewriting from product to sum. Now, sum as products. Cosine of 7 minus cosine of 3. So which one has a difference of cosines? This one, the last one. So this is a -2 sine of 7 plus 3 over 2 sine of 7 minus 3 over 2. And this just becomes, what is 7 plus 3? 10 divided by 2, 5. And 7 minus 3, 4 minus 2, 2. And that's it. But there's one more in this section. I don't know which one you're going to get on your test, but you're going to either get something like this or like the next scenario. Sine of 3 minus sine of 5. So the sine, subtraction equals 2 They're right, it's the right one. Blah, blah, blah. Give me one sec, because I think I wrote down the wrong one. No, it's right, sorry. So the first one we put is cosine. Yes. Cosine of 3 plus 5 over 2. And then it is sine of 3 minus 5 over 2. So this becomes cosine of, that's 8 divided by 2, which is 4. And this is sine, that's a -2 over 2, which is a negative. When you have the negative, you have to go and look at your even and odds. And when sine has a negative, where does this negative go? Outside. So this is going to become -2, because this negative has to go out here. Cosine of 4 and sine of a positive. So if you get a problem like this, I need to see where it's negative here, but then where the negative comes up front.
Because it's just go in front of sine.
Huh?
Why doesn't it just go in front of sine?
Well, it's multiplication. So if I put it here, you're probably going to think I'm subtracting them. So that's why you would write them all the way up in the front. So that is it for 7.7. Then we had 8.1. And for 8.1, let's say A, B, C, little a, little b, little c. If you get a problem where you have A is 8, B is 25 degrees, can you please find B, C, and A. Now, in 8.1, please keep in mind that these are right triangles. So if we tell you that B is 25, then obviously to find angle C, I have to do 180 minus 90 minus 25, and I figure out that C is how many degrees? 65. So this is angle C. Our angle A. I don't know why I put it's angle A. That's what you were looking for. Now, in order to find little b, here's little b, and they give you that this is 25, and they tell you this is 8. I could use opposite over adjacent. So I would use tangent of 25 degrees. Tangent of 25 equals opposite. I don't know my b over my a, which is 8. Cross multiply, you get b equals 8 tangent of 25 degrees. You grab your calculator, 8 tangent of 25 degrees, and I find out that b is approximately 3.73. Now to find c, I could use my adjacent over hypotenuse. So I could do cosine of 25. My adjacent is 8 over my hypotenuse, which I don't know. So SOHCAHTOA, this is 8.1 is where you do SOHCAHTOA. So C cosine of 25 equals to 8. Divide by cosine of 25. So C equals 8 divided by cosine of 25, which is 8.83. And there you go. It's a quick review of what it is. 8.1, 2, and 3 are the easiest ones on there. So that's that. 8.2, laws of sines. A is 7, B is 9, and angle B is 49. Now, do you remember your formula? Well, it's there anyways if you don't. What do we do? The one you know is sine of 49 over 9. And if, is that the what?
That's 21.
21? Which, yeah. Sorry. Number 21. So sine of 49 over 9 equals sine of A, which I don't know, over 7. So let's look for angle A first. We have to find everything that's missing. So this becomes 9 sine of A equals to 7 sine of 49. So in order to find, I have to do what? Divide by 9. And if I'm looking for an angle, when you type it in, you have to type it in how? With the inverse. So what is the inverse of sine when I have 7? Do you type in sine? Am I doing something wrong? I'm already doubting myself. Divided by 9. And that right there is 35.9. So yeah. So the inverse of that gives you 35.9 degrees. So if I already know this is your A, there's your B. In order to find your C is 180 minus the 49 minus the 35.9. So C equals 95.1 degrees. But I'm still missing finding who? Your side C. So sine of 49 over 9 equals to sine of 95.1 over little c. C sine of 49 equals 9 sine of 95.1. Divide both sides by sine of 49. And then you just plug that into the calculator. Which is 9 sine of 95.1 divided by sine of 49. And C is 11.88. So that's you having to use the sign of the law of sines. Are we okay there? 3 more problems to come, and then we're done. All right, so in 8.3, today we covered laws of cosine.
Sines.
Thank you. This is C, that's 6, that's 4, and this is 22. That's 6, 4, and 7. This is A, this is B, and this is C. And I am missing all my what? All your angles. So you would have to use the formulas with the angles where you're going to have to use the inverse. Now maybe you're going to get one of the other ones where they give you 2 and 1. So depending on what they give you is what you're going to have to use, right? So this one, really quick. If I'm looking for angle B, cosine of B, so this is your A, this is your B, and this is your C. 6 squared plus 7 squared minus 4 squared. All of this over 2 times 6 times 7. And you put that into the calculator with the inverse, and that's my answer is 86.4, I think. Inverse cosine, 6 squared plus 7 squared minus 4 squared divided by 2 times 6 times 7. And I got it wrong. Just kidding. So the answer, it's because it's B. So B is 34.8 degrees. And then you would do the same thing for the other two. All right, let me give you the answers. You could do that just so I could make sure. A should be 58.8 and C should be 86.4. Because there's 2 more, and the 2 more problems that we have are word problems. Because you will have 2 word problems on your assignments. So the first one, it says a radio transmission tower is 250 feet tall. How long should a guy wire be if it is attached, if it is to be attached 13 feet from the top and is to make an angle of 32 degrees with the ground. in this one, it does help if you draw little pictures so you can understand. Here's the tower, right? Whatever. Your tower's more beautiful than me. The tower is 250. You're going to run a wire, and it says with the ground, there is 30, just kidding. There is an angle of 32 degrees. But they mention 13. Now, basically, what they're trying to say is this, even though the tower is 250, it is not going to be 250. What is 250 minus the 13 that they're talking about? 237 feet. So you could think of it as it's off the ground or not, I don't know. So the numbers you're using is going to be the 35 and the 237, not the 250. So they want to know how long is this wire that they're going to put, how long is that going to be? So I have sine of 32 degrees equals opposite. The opposite is 237 over your hypotenuse, which is your wire they're going to put. So your C, I guess. And then you just cross multiply. I'm going to make that an X. X sine of 32 equals to 237. Divide both sides by sine of 32. And you're going to get the same problem, just instead of 250, 300. Instead of 13, 12. Instead of 32 degrees, same type of problem. So X equals 237 divided by sine of 32, which is 447.2 feet for the wire that they're trying to put. And the last one says 2 points A and B are on opposite sides of a building. A surveyor selects point C to place a transit. Point C is 46 feet from A and 64 feet from B. The angle ACB is 45 degrees. How far is A from B? So you have a building. You have points A and B on opposite sides. But it says that on point C, this is where they put the transit. So something like this is happening. The distance between A and C is 46. The distance between B and C is 64. And then they say that angle ACB, meaning this angle, is 45 degrees. What they want to know is, what is your distance between A and B? So when you're looking just for a side and they give you the angle, I could use the law of cosines. So this is going to be C squared equals 64 squared plus 46 squared minus 2 times 64 times 46 cosine of the 45 degrees. And I will get that C is 45.26. So you're going to get a problem similar to this one. Hopefully you can figure out that you have to use cosine. So this here is your review for your test. Your test is scheduled for Tuesday, unless a hurricane comes. Just kidding.